Until now, I have never really lived. Life on Earth is a creeping, crawling business. It is in the air that one feels the glory of being a man and of conquering the elements. There is an exquisite smoothness of motion and the joy of gliding through space. It is wonderful.
Power's off the reservation and I show 30% drain. My compliments, Centenary. Except for a slight malfunction and no to all access.
Discover the cutting-edge future of aerospace and innovation as we explore the current stalemate in Ukraine's war. Fasten your seatbelts as we delve into the trade-offs between modern and legacy air systems, the challenges of technology for an air force effectiveness, and the necessity of innovation in dealing with modern threats. Let's take flight into the future of air forces together.
We are ready to continue our exploration of the evolution of air and space power. This time, we will focus on innovation and on the difficult balance between a relatively small number of high-quality, expensive, cutting-edge technologies and a relatively high number of legacy systems, while also drawing lessons from the Ukrainian conflict. Our panelists will examine the organizational challenges that arise with aerospace innovation, including sustained investments, rapid prototyping, and agile organizations. Our moderator for this second discussion is an assistant professor at the Department of Political Science of Roma University, specializing in strategic studies. He has a wealth of experience, having been an Eisenhower Defense Fellow at the NATO Defense College, a postdoctoral fellow at Stanford University's Center for International Security and Cooperation, a lecturer in international politics at the University of Leeds, and a visiting scholar at the International Institutes for Counterterrorism in Erzulia. Additionally, he has also worked as a military researcher at the Military Center for Strategic Studies, now known as the Institute for Defense Analysis and Research. He is an accomplished author, having published many articles in the field of strategic studies. Without further ado, please give a warm welcome on stage to Dr. Niccolò Petrelli.
Good evening, everybody, and thank you for being here, and welcome to the panel on technology and innovation. We have an impressive group of speakers that I will be very happy to introduce to you, starting from Dr. Liran Antebi from the INSS in Israel, senior researcher. Professor Justin Bronk from the Royal United Service Institute. Brigadier General Vincent Chusseau, commander of the Centre d'Expertise Aérienne Militaire. Major General Stefano Cont, director Capability, Armament and Planning at the EDA. And last but not least, we have Dr. Franco Ongaro, Chief Technology and Innovation Officer from Leonardo. Okay, let me start by having the survey launched, please. Okay, so what is you can vote with your QR code, and the question here is a very important one, is about the optimal speed of innovation for air and space organization. Is it best guaranteed through a first mover posture, a fast follower one, a hand-in-hand military-civil dual-use technology development, or a commercial off-the-shelf approach? Please vote by using your QR code, and we will discuss the output of this survey in the Q&A with our experts. Okay, I would like to start to kick off our panel with Professor Justin Bronk. So, Professor Bronk, tell us about innovation in peer conflicts. What are the key ingredients? Please, floor is yours.
So a small question to start, right? So I think the first thing I would start with is that innovation for peer conflict is not symmetrical. So often discussions around technology areas that are seen as critical to innovation, hypersonics would be one I'd look at, or AI or various other ones, mean very different things in terms of potential advantage, cost, the difficulty of fitting them into existing force structures to different actors. To continue with hypersonics as an example in that, for most Western militaries, hypersonic weapons are a very serious threat because our force structures are essentially postured around very, I wouldn't say elite, but extremely high capability assets in relatively small numbers, facilitated by a very, very sophisticated command and control and enablement, concentrated around key nodes. So whether that be combined air and space operations centers, aircraft carriers, super bases like you have at Ramstein or Mildenhall, let's say. Therefore, we've invested, or rather the US has invested a lot in missile defense, but hypersonics threaten to make that very, very difficult to prevent at least some leakers getting through. So we're vulnerable to a few very high value rounds getting through. For us though, yes, there's the pressure to catch up. The hypersonic use case is actually probably more complicated. There is a responsiveness point of saying we want to be able to more reliably hit mobile targets, particularly transporter erector launchers, for anti-ship missiles or opposing hypersonics before they move. So definitely there is value there. But that's a relatively definable target set. And it's not the same necessarily strategic game changer that it might be for opposing states looking at us. In fact, in many ways, against Russia, certainly for NATO, the problem is not that we don't have weapons capable of hitting the target. It's that we don't have enough of them. And going hypersonic means massively higher cost per weapon, much larger weapons for a given range, generally speaking, fewer available launch platforms, et cetera, et cetera. So actually, in many ways, it makes the problem more difficult, not better. So innovation is not a kind of coherent space across every technology for every actor. In terms of lessons specifically from Ukraine, obviously, as has already been mentioned, the key one is, I guess, scale. peer conflict between large nations or blocks of nations is, I would say, almost antithetical to the idea of short, sharp victories. Even if you have massive campaign reverses, just the geography generally involved will mean that either new fronts can be opened up if one side is pushing everything down one axis, or as we saw in, for example, Kharkiv, where the Ukrainians had great success, they simply outran their own ability to push their supply lines forward and to, keep replacing and replenishing those spearhead units. So, even if you have fantastic technology, ultimately you're going to have to be able to fall back on either mass or redundancy in terms of other systems. Western air defense systems sent out to Ukraine are a great example of innovation over time. As we saw from the Kinjal interception, PAC-3 intercepting a quasi-ballistically maneuvering, quasi-hypersonic air-launched ballistic missile is almost a miracle of science and technology. On the other hand, despite the PK, the probability of kill of most Western air defenses being sent to Ukraine being very high against the targets they've been employed against, they just ran out of ammunition. And so, the same goes for a lot of the kind of high-end capabilities Russia started the war with. Even where they worked pretty well, they were then used as spearheads everywhere, whether that be elite formations or, units with elite equipment. They are then just attrited over time because even with very, very, successful employment in cases, there's just too much to attrit your way through, and so those units eventually get ground down. And so over time, you've seen replacement with mass of high tech. Clearly for us in the air domain, it's important to prioritize what the actual ask is, because innovation for its own sake is very interesting, but ultimately is not going to get you a coherent force structure.
Yeah, and if I may interrupt, isn't, in your opinion, the danger of sometimes overcomplicating requirements and, as you said, innovating for the sake of innovation? I mean, getting always the most novel, the stuff that you can get, the best around.
Everybody wants to have the best around, but in all seriousness, there is always a desire in the West to go for the best equipment possible because we want to give our people the best chance of coming home when we send them in harm's way. So, gold plating has a point beyond a sort of optimal force balance. It's also about giving people the best chance of staying safe. But I think it's more, I would suggest, key to prioritize the mission sets and the outputs that you really require. And that will guide you as to where you might want to put, veer or haul investment levels in really exquisite kit. To take the kind of European requirement close to home from Ukraine, let's think about the requirement. The requirement is ultimately to convince Russia, which is very unlikely to stop its ongoing mobilization rounds. It's very unlikely to take its industry off the war footing they've now put it on. And it's unlikely to be able to come back from the confrontation that its leaders have jammed it into and then doubled down and doubled down and doubled down on as things have gone wrong. So however things shake out in Ukraine, we have a requirement, a Russia problem if you like, to deter Russia from attempting military aggression, either to regenerate conventional deterrence credibility against NATO as they see it, or to just try and redress the wrongs that they will now feel they have definitely built up. We have, after all, supplied equipment to kill hundreds of thousands of Russian troops, or at least wound. So, there is a confrontation coming. So what's the requirement to deter that from happening in the concurrent case? And let's be clear, if the US is playing, all in Europe, we probably are all right with the force structure we have. The problem is the concurrent threat, which is if and when something happens in the Taiwan or the Korean Peninsula, the US is likely to have very few assets to spare to reinforce Europe for a considerable period of time. In fact, they may well be pulling assets and logistics out of Europe and CENTCOM in order to push into the Indo-Pacific. And that is the most likely time for Russia to do anything because it's in their interests to pick the time the US is involved elsewhere. The Chinese might also ask them or supply them or help them to take the pressure off any European reinforcements. So we need to be able to deter that. How have we always deterred the Russians? We've deterred it through exquisite air power. We deterred it essentially through the 1991 model. That is, we will roll back your air defenses and then we will vaporize any ground forces at leisure and then roll in. Now, that is a model that works staggeringly well when you can do it. It genuinely is the exception to the general rule that state-on-state conflict doesn't happen quickly in terms of decisiveness. If you can get air superiority and let Western air power do what it's already very good at, close air support, battlefield interdiction at scale, and going after deep targets, then yeah, we don't have a Russian military problem. The problem is we can't do that. Why can't we do that? It's not because of the VKS, the aerospace forces, it's because of the ground-based air defenses. So, for innovation and indeed just force redesign, our problem has to be, how do we roll back those Russian air defenses? The good news is, it's an entirely solvable problem. In fact, we've been innovating on the side, just not deploying at the scale, over the last 15 years to develop technologies and capabilities that will enable us to do that. Things like F-35 with a sensor suite particularly designed to be able to, while getting close enough, geolocate SAMs immediately when they come online as a foreship, and weapons like Spear 3 or GBU-53B or AARGM-ER, which are able to not only rapidly get to the target, but also have a reasonable degree of terminal survivability and hunt and kill those targets in a hard sense, even if they're not illuminated by that point and moving. We have these systems. We've been innovating over the last 15, 20 years in case we ever had to face this problem. We see that in Ukraine now. NLAW, Javelin work phenomenally well. Starstreak worked phenomenally well. Patriot is working phenomenally well. Our weapons and our innovation cycle isn't actually as, they're not as slow and glacial and all of that as we like to tell ourselves. They're actually working brilliantly, at least against the Russians. China's a different problem. So, yeah, concentrate on the threat. What do we need to do in Europe at least? We need to be able to kill Russian air defenses at scale. We have the technology, now we just need the scale. And so, because if we can make them go away, then the Russian army is not a problem. We just don't have to worry about it. So in conclusion, I would say, what do we need to make that happen? It's probably actually just going back to basics. It's remembering that most of what we talk about in innovative terms, whether it's novel C2 systems, implementation of AI, hypersonic weapons, advanced EW, all of them are enablers. They are about enabling your force structure to do more and more effectively. But the problem is, if we don't have a coherent force structure underlying that, you're not enabling anything. We currently rely on enabling American logistics, munitions, and scale, with some European add-ons, if I could be crude. And so it's just about building back up the basics of what we know we're all good at. We've all been good at. It's good DCA, it's good OCA, it's good CAD, it's good DAD, and it's a measure of hardening, a bit of dispersal, and air defense to make Russian long-range precision strike unacceptably inefficient in taking out our air power, and so that we can absorb blows and keep fighting. It's not that difficult a task, but it will require innovative processes and innovative thinking, even if the technology is largely already in place.
Thank you, Professor Bronk, which leads me, when you mentioned getting to the basic innovative thinking, it's a perfect conclusion to get into the next topic for discussion by Brigadier General Chusseau. So my question for you, Professor Bronk said, let's get back to the basics. And therefore, let's try together to get back to these basics and find out how do we move from the spirit of innovation, the original conception of innovation, to operational efficiency in the innovation process. Please.
Thank you very much. It's a great pleasure and a great honor to be in front of this distinguished assembly. As you know, I'm the Air Warfare Center, the French Air Warfare Center commander. So I will touch down this subject by the French perspective, with maybe a day-to-day issues we are dealing with. So Air Warfare Center was first focused on operational testing and evaluation. And since a few years now, we have moved from this testing and evaluation to more tactical thinking, doctrine, lessons learned, and innovation. And I think it's very coherent to associate innovation with all those development processes. Our process in innovation is based on different apps, a different way to help the innovators, to guide them, to support them, to the demonstrators. We use different resources from the air bases, from the Warfare Center, from the staffs, and also from the innovation agency, from our procurement agency. In that way, last year, we have witnessed a very significant increase of innovation registrations in our database, plus 70%. And I think it's not a coincidence, and we hope it will continue. It's not a coincidence because I think we have developed our facilitator and incubator capabilities. We have shared different experiences and best practices, different labs, all in the air and space forces, about 10. But also with, of course, due to the Ukrainian conflict, where there is a crucial need for innovation, and also it's a source of inspiration for innovators. The confidence for innovators has increased, and we are trying to renew to this innovation spirit. This innovation spirit is a specific mindset or DNA of the aviators to always look forward or to look out of the box in order to gain operational superiority against evolving threats with limited resources. So before going to where we stand and when we can go, I would like to make a specific focus on where do we come from. More than 100 years ago, at the beginning of aviation pioneers were both innovators and test pilots. They were used to take from the shelf, off the shelf, some different aircraft, to put some wheels, to put some speed indicators, to put armament systems, and to test them. It's like Ukraine are doing today with different capabilities, different large-scale capabilities. So they had this innovation spirit, and they were able to make it real, but with some risks, of course, and it's very important. Then processes and organization were shaped progressively until nowadays. So we started to talk about programs, to talk about requirements, and then came the regulations. Some were coming from the civilian side, like airworthiness, and others, like cyber protection, were here to protect the different equipment. We talk about certifications, the compliance to regulations, and qualifications, the compliance to requirements, for the sake of big programs, such as aircraft, armament, C2 system, or GBAD. But those regulations and processes are here to protect aviators, to protect equipment and people, but they are created some major constraints restraining the innovation spirit and the chance to make a quick bottom-up approach successful. So with this context, the question is how to renew to this spirit innovation and how to find out some rooms of maneuver to make it concrete and efficient for operational superiority. Before touching that subject, I would like just to make a quick overview on what we are talking about when we talk about innovation. The Ukrainian conflict shows us that we need a perfectly balanced need between high-end capabilities and innovative solutions generating high effects. It's very important, so it's a question of agility and responsiveness for operational superiority. For high-end capabilities, we are talking about a top-down approach. We are talking about planned innovation coming from R&D, research and development, long-term cycles to develop and to update. Those capabilities, those innovations are necessary for air superiority and to secure operational environment in multi-dimension operations in a perfectly coordinated engagement. On the other hand, we have a top-down approach with open innovation. This open innovation can be very efficient as long as they have short-term cycles and some risk also are accepted in the development and employment. The point is to find out a coherence between three criteria we use for innovation. The first one is effectiveness. Effectiveness is a response to the requirements without consideration of the limited resources or long-term support. The second one is the relevance between the type of the capability and the effect to create. This is the limit of the concept fit for all solutions, in fact. And efficiency, the last one, is the optimization of the means and their cost to the operational result.
General, sorry to interrupt. Now you I think it is the right moment to raise a question that's relevant to what you just pointed out. And this is a concept that was mentioned by the Honorable Chusseau in a keynote speech. It's about the valley of death in procurement. So how do you think it is possible to get out of the valley of death? What are, in your view, the most important variables in getting out, especially in large procurement programs?
Yeah, for innovation, of course, there is some constraint also. The constraints are sometimes procurement constraints or legal constraints, or even resources, or even motivation from the innovators, because to go from a demonstrator to a large-scale capability or at-scale capability, you need some effort, and it can take some time, and it can be demotivating for the innovators. So what we call the valley of death, the way to scaling up a capability, and to ensure that we are coming from effectiveness purely to relevance and efficiency. So this valley of death, we need to have a multi-dimension approach to fight this valley of death, to cross this valley of death between resources, organization, and equipment. So I would like to elaborate on that with different examples to show you where we can find out sometimes some good practices, some rooms of maneuver. The first one is dealing with the optimization of resources. So we try to look on off-the-shelf capabilities, taking from the civilian side, of course, and to have a minimum of adjustment and to reduce by the cost, to reduce the time by reducing the requirements also. Two examples for that. The first one is what we call massive network simulation. So massive network simulation is coming from the serious gaming world, and the aim is to train crews on coordinated tactics for high intensity. And it's very effective, and we are deploying different kind of cockpits now in France on the different air bases to ensure this connectivity between different simulators with a very relatively low cost. The other one is all we can see about adaptation on UAVs also. On UAVs in Ukraine, you have seen different capacity adapted on the off-the-shelf UAVs. It's very easy to do that. The second axis is to tackle down the regulations problem. So for that, we have to renew with operational risk management. It's something very important. Within the French airworthiness regulation, we have the chance to have a derogation, an Article 10, which can be used when we are not able to reach qualification, certification, all the criteria for airworthiness. So for that, we have a specific framework based on a robust process. So it's for specific circumstances, for operational use mainly. It's not the rule. We are always looking for compliance in parallel, but it's a way to move forward under operational pressure with risk mitigation and when we are not able to quickly certify. For that, I have a good example. During the COVID-19 crisis, we were able to adapt medevac kits on a helicopter, Caracal, in 3 days, and A400M in 1 month. And we were able to deploy immediately the capability with this Article 10. So it was a combination of different innovative solutions, electrical converter, air filtration, oxygen dispenser, and of course former medical kits, but it works in a very few days. It was very effective. Of course, we have other examples with special forces because they are used to need some very quick response. So you can elaborate also in ISR or C2 capabilities for them. And the last point to tackle this issue of Valley of Death is looking deeper in the design of the different capability at the beginning. I mean, we have to be able to integrate smoothly, seamless, open innovation during the life cycle of a capability. But for that, you have to design it properly at the beginning with an open architecture What is an open architecture? It's an architecture able to plug and play different capabilities, of course, but also to have those capabilities able to evolve very quickly. It's more adapted for information systems, but it's very efficient. We can have, for that, in different main capabilities, some protected area of the system, and an open area by design, where you can move very quickly when you need it. We have different examples in the C2 systems, or even on fighter aircraft. But the aim is to put in the hand of users this room of maneuver, this new space, to develop their own application to increase situational awareness or to increase the decision-making process. So those capabilities, this principle of open architecture is something we have to incorporate for new capabilities, for new aircraft, but also for combat clouds or system of systems from the very beginning. It's very important. So to conclude, I would say that for sure there is no comparison with Ukraine regarding innovation, because for them innovation and survival are at the same level. But aviators' innovation spirit is a competitive advantage we must take care and we must develop in our country. I'm really convinced we still have some rooms of maneuver in our organizations and processes before changing them to better foster innovators' confidence and ensure complementary between planned innovation, long-term innovation, and open innovation, short-term and very reactive innovation. This is a question of operational efficiency for operational superiority. Thank you very much.
Thank you, General Chusseau. Okay, so up until this point, the panel is called Technology and Innovation, but what surfaced in the first two presentations is of course, we all know about it, the relevance of non-technological factors in innovation. And that's the topic that I would like to address with our Dr. Antebi. So how do you combine technology with soft factors for a balanced force build-up? Because force build-up, force development is really the topic here. How do you get a balance for structure, and how do you combine technology and soft factor?
Thank you. So first of all, thank you for inviting me for such a wonderful event. I'm also calling them most of the time soft factors, but it's important to say that they're going to be as soft as colliding into a wall in 100 kilometers per hour if we won't be ready in manners of the soft factors. So not so soft. Anyway, I'll start by arguing that the aviation and space industry has been at the forefront of technological and conceptual innovation for years. And most of the successful operational achievements in the field have occurred through the integration of innovation in technology and perception together. I have several examples that I really love to teach when I'm teaching my students at home. For example, the 1982 Israeli operation Mole Cricket 19, while they used UAVs to destroy Syrian aircraft defense. And it was a major success with innovation in technology and perception that nowadays sounds very basic. That's funny. Another example I have to teach is the opening strike of the Second Gulf War. They have used a lot of JDAMs under the perception of shock and awe, and it was once again combination of innovation in technology, very precise technology, and innovation in perception. And today it also sounds very basic. Actually, I think I should change the slides of my course, and I can't call those cases modern cases anymore because technology and perception changing so fast. So I come to say that our work is under a significant change, particularly in the sphere of technology. I think that, for example, what's happening these days in the field of AI, ChatGPT, and other very large language models that really changing the world. It's some kind of tectonic changes with a lot of implications for many fields of life, not just national security. And finally, they're also receiving enough attention even from decision makers. So I don't think I have to elaborate. I think that the disruption is really clear lately. And air forces, military forces and air forces also being disrupted and paying attention to both the capabilities and both the challenges coming from those technology. So on one hand, we have technology that's changing in the fastest rhythm in history, and on the other hand, we have large systems like air forces that sometimes struggle to keep up. And the challenge not coming just from the pace of technology, it's also coming from the capabilities of several of our adversaries, particularly non-state organizations, to adapt, because they are much more quickly, they're taking off-the-shelf technologies, and they have a lack of bureaucracy and structured processes that sometimes allowing them to do things. And also, they're doing things that we're not thinking to do with technology due to moral reasons and legal reasons. So air forces that used to lead in innovative technologies suddenly finding themselves struggling to keep the pace with civil bodies and adversaries. And this is a real problem because air forces still require to deliver like before and sometimes even more. So I'm seeing a lot of good examples of how to handle with those problems. Sorry. One of the examples arriving from the Ukraine conflict. For example, you can see a new approach of the Ukraine forces. They're taking very skilled people from the technological field and putting them inside the troops, inside the fighting troops, some kind of technological officers. Those people, they are not just skilled in manners of technology, they also understand the big picture of what's going on with the troops, and they are more qualified to give the correct demands of technology and really help to implement them much fastly and to get more of them when it's coming to the field itself. And actually, in our days, it sounds reasonable to have such a role, maybe even in every unit, someone that really understand the big picture and understand technology and can help you combine between the things and not create border between the technological jobs and the operational jobs that many times we have in forces. And we were talking about the soft factors in force buildup, and I think that we must approach and adopt more holistic approach to handling with those challenges. I'm calling it the top challenges.
Okay. Okay. So, what do you mean by these top challenges? What does it mean, top?
Yeah, you were disturbed by the top all the time, and I promised to explain. So I just call it top, so it will be easy to remember. Now you all remember. You have no choice to remember. So T stands for technology, O stands for organizational, and P stands for personal, really personal things like politics and people that feels uncomfortable with technology. I know several people like it. When I'm speaking about technology in the top, I'm not speaking about the systems themselves. I assume that our industries are very capable to produce great technology, but I'm speaking about the fact that sometimes we look at those technologies and we are saying, oh, they're very expensive, sometimes the cost is unbearable, or we have a lack of flexibility within the solutions. So sometimes we have to handle in the soft factors inside the T of the technology. The organization, for example, is changing in jobs, in positions, in training, and many many other factors, and also sometimes legal and ethical implications that coming with the technology. When we are looking on autonomous systems, those are things that are very, very important, and they're not soft at all, as I said before. And personal, as I said before, at the end of the day, we're still working with many, many people, and we have personal things to take care of. We want people to feel comfortable with the technology, near the technology. We have issues of man and unmanned teaming and others, and of course we have issues of politics that sometimes inside organization that sometimes can really, really stack very good technologies and very good processes. So in order to handle with those top challenges, there are several methodologies, and you probably will be surprised to hear, but most of the knowledge about the problems and the solutions are within the troops themselves. The only thing is to extract the knowledge that your people have inside the organization, and there are several methodologies that can be used. I were using them in researchers inside Israel, and sometimes with international panels. And
tell us more. We are very interested in this methodology.
And another surprising thing is that they are inexpensive at all, because when you're taking a research with people that extracting existing knowledge from people that inside within your organizations or partners, and it's help you to get a better implementation of technology that you paid so much for. This is really, really inexpensive way to improve what you can get from the technology, and I think it's really necessary and important. It may sound hard, it is, but the good news are that it's totally possible, and that sometimes you'll be surprised that the solution are just inside your organization. I want to use what I explained till now in order to answer one of your questions while shaping this beautiful panel. You were asking whether it's better to have a small number of high-quality systems or a large quantity of more affordable ones. It's a great question, but once again, I want to go to the soft factors and relate to how we use what we're choosing. Oh, it's work? Yeah. How we use what we are choosing. In my opinion, by addressing the soft components and taking into account factors such as adjusting doctrine and integrating the airborne system with a large framework of technologies together with the right organizational changes, we can create a greater value from systems we have chose. I want to give an operational example from the Israeli Air Force and from several recent operations that the Israeli Air Force was participating at. The Air Force uses combination of advanced platforms like the F-35 and older platforms like F-15, which has been in service since, you know when? December 1976.
Not bad.
Not bad at all. They look totally new. Anyway, the Air Force also employ UAVs, some of which are older, while others are newer. And it also, the IDF itself also operates many types of small UAVs and rotary drones by the ground forces. So many different kind of aerial systems working together. But lately, we see an improvement in operations. In the ability to carry out air operations successfully, and part of the improvement is coming from the usage of AI, especially for intelligence processes. So people really love numbers, so I brought you some numbers, okay, so we all feel more comfortable. So in Operation Guardian of the Walls 2021, for example, the IDF itself produced 200 high-quality targets over 12 days. 50% of them were attacked by the Israeli Air Force. Prior to this operation, in order to create such a number of high-quality targets, it took nearly a year. And the change, yes, it's a tremendous change. And the capability comes with the AI, but not only with the technology itself. It also required many changes in how the procedure is working and how the people are working. So someone took care also of part of the top challenges and not only brought an amazing technology in order to create and to achieve a greater success. Now, due to the fact that we are in Rome, and I'm really impressed by the beauty of the city, the people, and the food, and due to the fact that we are after lunch, so you're not going to be starving after what I'm going to say right now, I'll give you the following analogy. In my opinion, when it comes to artificial intelligence and air power, it's the perfect combination, the perfect match, like pasta and pecorino cheese. Yeah. It's delivering amazing results with only 2 ingredients. And of course, it's important to have a very good quality of the ingredients. But it's good, but not perfect. If you want a genius dish, like the Roman cacio e pepe dish, you need to add another thing. You need to add the black pepper, and you need a talent to execute. Because if I'm trying to do it, it's not that, okay? You need a talent. So, thank you. So in our case, we have the AI and the Air Force as the pasta and the pecorino cheese, but the black pepper, in my opinion, should be the relevant doctrine, changes in the doctrine that will be relevant, and I hope you all trust the talents at home to execute perfectly. So I think that now, after all, you're all starving, so but also very focused, so we'll conclude. In order to achieve a greater profit, we must address the needed changes in more holistic way. Don't forget to tackle the top challenges. Now I'm sure that you remember, not just the cacio e pepe, but the top challenges as well. And don't forget to combine between different kinds of innovation. It's very important, not just technology. It's indeed a challenging and Sisyphean task. However, it's an opportunity to collaboration between like-minded states, sometimes with common adversaries. So let's try to be much more effective by trying to solve the top challenges together. Thank you.
Thank you. So, you know that you are really talking about innovation when Italian cuisine surfaces in the discussion. So with this, I would like to move with the last 2 presentations about the process of innovation. And so let's move to take a look at the models through which you can really foster innovation. So my first question is for Director Cont. How can innovation be a force multiplier? What kind of models turn innovation into a real force multiplier? And fundamentally, a very straightforward question. What are you doing at the ADA that can help?
Well, let me start to say that it is a real pleasure for me to be here today to honor the Italian Air Force is in its 100-year celebration. And let me try to give an answer to your question in telling, first of all, that yes, innovation is a real force multiplier, but only if it leads to disruptive capabilities. So my focus today for my brief presentation will be on 2 points. First, on what we mean at EDA for innovation and how we pursue that, and then on how to be disruptive. That it probably requires a little bit more of discussion. You know, in EDA, we created the Hub for Innovation a couple of years ago that is now developing its capability. And let me tell you what is the concept that drive our activity during the work that we do in the Hub for Innovation. We strongly believe in the Schumpeter, that was in a way the inventors of the term innovation, you know, on his definition. He says that innovation means to generate a change to find truly new and advantageous solution to often older problems. So it doesn't talk about technology, doesn't talk anything specific, it talks about new ways to do stuff. That is the real concept of innovation. Yes, we acknowledge that new technology is definitely make it possible to develop better capabilities, but we do also believe that a poor technocratic approach to innovation not always guarantee to reach the objective. Innovative, in fact, is not a synonymous with inventing or improving, but and not always in a higher technological level guarantee in itself a competitive advantage in an operational world. We have many historical examples that can prove that, and even recent lesson learned from what is going on in Ukraine can, in a certain way, prove some of those elements. So, from an EDA perspective, what are the characteristics that a true innovation should have? Well, we think are essentially three. First, innovation should be connected to operational needs and requirements. Yes, we do not underestimate the potential for open innovation and the impact on military capabilities. But regardless on how the innovation is started, the fundamental point for us is to assess its usefulness and the success, looking at its relevance for the needs of the end user. So for us, the end user is always at the center for all the activity we do. Second, innovation should be anchored to a true capability-driven approach. Real innovation requires a truly systemic approach. New technologies, new capabilities, actually, to be more correct, require new organization, new logistical structures, but above all, require change in the selection, in the education, in the training of the personnel. And so, as we can see, is much more than just technology. Third, the today geopolitical environment that this morning was very often referred to suggests that innovation should be characterized by proper speed of relevance. What I mean is it should be addressing the pace of needs and be driven by a quick and integrated process of experimentation. That in this experimentation, we have the end user, if you want to use this term of the defense forces, the militaries, you know, really in connection to the guys developing the new capabilities. Why that? To verify the real operational utility since the beginning and to proceed in a very quick pace of advancement. Obviously, this will require a stronger interaction, a much stronger interaction than today between the user and the industry, and I would say even with the academia. So said, let me move to my second part of my intervention and try to say how this innovation relate with the future of the air power. And again, here the central element that we are trying to address is the need for new and innovative concept of operation to be able to drive new architecture and solutions in a way that all the innovation is in a way contained in this path. And I give you two elements that we are, conceptual element that we are really exploring right now in the agency. The first one, we believe that the center of gravity of the air power is progressively moving up vertically in the third dimension. What I mean is that the lowest part, the atmosphere, we can use a naval term here, the brown sky, you know, it starts to become too much congested and crowded to be able really to maintain air supremacy or air dominance. Probably We think that future true air power effects will be achieved by mainly operating in the so-called blue sky, the upper part, an area that is also expanding due to the progress in technology. And again, I'm connecting to what was said this morning in the previous panel. You know, the new possibility to effectively operate above the traditional 20 kilometers ceiling up to the Kármán line. You know, new technology like hypersonic or suborbital flight can really open up to true new aerospace capability with systems that are able to operate in and out low orbit. And this possibility will allow really air power to become aerospace power, traditionally overcoming some limits like reach and persistency to achieve both a global effect and a real defense in space capabilities. So these are the concepts that, the first concept. The second one is air power that we think that we will have to deal with the evolution from solutions that are centered on platform and pilots to a more complex and sophisticated, if I can say, system-of-system approach, where piloted, remotely piloted, space-based, and drones platforms operate in an integrated but distributed way to achieve the desired effects. So, if I can be provocative for us, more than any discussion on what represent a fifth or a sixth generation fighters, we are trying to interrogate ourselves on what are the key capabilities for a fifth or a sixth generation of air power, much more integrated. Now, the final consideration on how to be disruptive. And here we have four main problems, let's be honest. The first one, long time requirement required for the introduction of new system into service. Takes too much, too long. The second one is the management of the rapid evolution of technologies that makes systems sometimes obsolete even before they become operational. Or, on the other side, it leads to handleless development phases. The third point is the expansion of digitalization, and that require interconnection of capabilities. And what we observe is that our system lack interoperability by design. And not having that, it will require costly activity to make the system interoperable, and even reducing the possibility even to create or optimize product for different customers, and that reduce the possibility for true cooperation among different industry and nation. And the final point, probably the most relevant, is that the cost for the three phases, R&D, production, and sustainment of a new aerospace systems has reached levels that are honestly unsustainable, even for the biggest countries. And real here, we think that the right solution is not just an evolutionary solution, but what we think is that we have to have a new, truly innovative approach in addressing capability development. Yes, please. And key for this one, we are working on a concept. And for brevity today, let me mention only one of the different concepts we are exploring, that is the digital acquisition approach. It's nothing new. It's something that it was theorized and put in practice in the United States in 19. It's something that comes even out from different experience. And let me tell you the three concepts for this element. The first, defense should own and share the set of technologies that they have available to ensure better interoperability and in a way to be in the drive for future capability. Second, we should move quickly from computerized development to deployment to avoid delay, additional cost, and to be sure that we can introduce new innovation really available even in a project that is already on its move. And the last point is that we should create before flying something. So this is a concept that is done in Formula One. We're where right now, you know, a car get produced only have been fully, completely digitally engineered. And I think that realizing e-planes, e-satellites, e-weapons through a full digital engineering process will reduce the prototyping phase to the minimum possible, and definitely will reduce the cost of the whole systems. For the sake of time, let me just say a final concept. That if I can translate that in a jingle for today, for me, is that we need disrupting concept to drive or to generate disrupting technologies with the aim to achieve disrupting capabilities. And disrupting capabilities is always our real end states that we have to reach. And I think I gave you the possibility to recuperate sometimes in the speech today. Thank you.
Thank you, General Cont. So before moving to our last speaker, I would like to remember you to use your QR code to vote in the survey so that we can discuss the results in the Q&A. And now, last but not least, I will leave the floor to Dr. Ongaro, and I would like to ask you a question. We've been talking about innovation, and as I mentioned, now I want to move to the later stages of the process. So how can you move from innovation to product? And maybe if you can mention specifically how the Diana model, what are the most important, the key factors in the Diana model that make it an effective one? Please.
Well, first of all, thank you very much for inviting me here, and my biggest congratulations to the Italian Air Force for their 100 years. It's a fantastic moment. Of course, it's very difficult to be innovative after the whole panel has spoken about innovation, but I'll do my best. Let me point out that, yes, we look for disruptive innovation. We also have to continue to develop things which are better than the ones we have. And in this particular point of view, I think we have, before coming to the last stage, as you mentioned, we have at least a few areas in which we have to really move forward and, let's say, be innovative in the way we do things. First of all, we have, as Leonardo, one of the most powerful high-power computers around. And the way that enables innovation is that when you run the code to design the aerodynamics of an airplane or an helicopter 150 times faster than what you used to do before, that changes the whole process of design. It's no longer a verification you do every 6 months. It's something you can do in a matter of days. And that comes to the speed we were talking about. And of course, that digitalization is looking to things like the digital twin in a real sense, something that can translate, hopefully, in your piloting a plane where you haven't yet started the production, and hopefully you start to get it qualified even before you start the production. And that is something we're working on. And a Formula One was mentioned, making a supercomputer work faster. It's not only a matter of getting a lot of servers, it's a matter of taking old software and converting it in a way that will run faster. Having a supercomputer also means you can run all the machine learning code and getting new AI deployed. And that means you can also find out what is the best algorithm of the AI that you want and use only that on a much smaller computer on board your platforms. And clearly, this drives toward a capacity for simulation that today you don't have. But you have to have it in order to simulate a battlefield or an intelligent city where everything becomes a sensor platform and has to be connected with everything else. And that connectivity has to be reliable, but most of all secure. Space for years hasn't looked very much at cybersecurity. It wasn't supposed to be a problem. Now cybersecurity has to be at the origin of everything you do. It has to be safe by design. And this connectivity is really the backdrop of everything we'll do in the future. And when we come back to the original question you asked, to a certain extent, well, we see it already because we're suppliers of trainers, which are very successful in the world. The more advanced your simulation becomes, the more trainers you have at your disposal to fly, because a lot of flight hours can be done on the simulators. And that, it's a multiplier of a limited asset. And this is the way digital takes a 40 years plane and makes it an up-to-date machine. And therefore, a lot of what we do goes in that direction. But I don't want to leave you with the idea that we'd only do digital. So, except that, of course, system of system will require mountains of software and mountains of people to code. But, of course, autonomy and robotics come out of that. And we also do materials, because things in the end have to be built. So you want to have lighter material, smarter materials, and less observable materials. So all of these are areas that we, and of course, space, last but not least, but space that requires, again, an enormous digital speed to be able, with the sensors we are developing, to understand what a footprint is and translate that in an immediate warning that has to be acted upon very quickly, because hypersonics, by definition, are pretty fast. And therefore, all of this is something we're working on to improve with our traditional way. We have 12,000 engineers, all of them innovators, and all of them working in our divisions in R&D. Then we have 11 labs, which work on specific technologies, from quantum to electrification, to make sure that we can push this. And then finally, of course, 12,000 are many, but they're not all. So you're looking for other sources of ideas. And this is where you come to open innovation. And open innovation, we have our own business innovation factory. We have collaborated with Aeronautica and Segre Difesa on the GCAP competition for ideas. And systems like Diana are fundamental, because they're looking for disruptive technologies on the market of startups and, let's say, free innovators, and they're trying to attract them to a world where these innovators are seldom attracted for two reasons. First, they fear they will not be accepted, and second, well, if you do something that goes on a smartphone, you have a market which is more than the population of the world. So the attractiveness of making a few things very expensive with respect to making many, many reasonably expensive, then, we need to have a means to attract these people, show them a path to the kind of innovation we need, give calls which are targeted so that we don't just get any idea, but the ideas that are useful to us. And most of all, I think it's very useful to have at a NATO level, because it's just, as we mentioned a few times, it's just at the inception of a system that you make sure that that system will be open, standard, and interoperable. Otherwise, many national systems which develop only at national level will result in a large number of non-interoperable solutions. So that for me is the big value of this approach. And if I come to what I think was the last part of your question, how do we go from innovation to actually deploying? I think one fundamental factor is what we call a proof of concept. Others call it the minimum value products or whatever. But you have to drive very, very quickly to a demonstration that what you're working on works. In a small setting, in a reduced environment, whatever, but that the fundamental idea works. And there it becomes much easier to attract confidence from the ones who have to decide where the money goes and go above, let me say, the value of that. The other thing, which is, I think, typically European, it's the gap between the developing an idea that works and the industrialization of that idea. Technology is relatively easy. Producing at scale, it's the real challenge. Producing reliably, repeatably, economically, something new. And that is a challenge that it's often overlooked. And if you want to attract the best to actually do that, then you have to be ready to make an upfront large procurement, which makes one essential difference from an observer like me from what we see happening in the United States and what we see happening in Europe. So I hope that EDA and the Commission will move on to this direction. Thank you.
Thank you very much. Okay, moving into the Q&A moment, beside commenting the results of the survey, which we'll do in a minute, I want to challenge you with a question. I mean, all of you, you are very knowledgeable experts about innovation, and you have firm beliefs about what is key to innovation. How did the war in Ukraine shake this belief? What happened? What did you witness that said, okay, this I didn't expect, this will lead to review my beliefs on innovation? Just before you get think about it, and we'll take a look at the results of the survey. So, hand-in-hand military-civilian dual-use technology development has got 62 of the votes. 29 for a first-mover posture in order to guide the private sector technology. Fast follower posture, 7%. The commercial off-the-shelf approach, I guess, didn't get much favor, 2%. So, whoever wants to start by giving his 2 cents on the hand-in-hand military-civilian dual-use technology, and to the question I've asked you about how did Ukraine shake your belief about innovation? Who wants to start? Okay, please.
When I'm looking at the war in Ukraine, and I'm actually writing a piece about the subject right now and about the usage of advanced technologies in this conflict, I'm actually surprised by the usage of off-the-shelf systems that got the smallest amount of voters here. Sometimes for the Ukrainian forces, and it's really making a real change. I'm speaking especially about the usage of artificial intelligence off-the-shelf products, part of them speech-to-text products, some of them face recognition products. And they are the system required in the place required without too much thinking, too much development. Sometimes it's the relevant solution that's required that can come really fast in not very high costs. The problem that it's not relevant for any cases. Of course, it's not relevant when we are speaking on a large system, on airplanes and things like this. But when we are looking on the large picture, I'm surprised by the usage of those systems and how effective they are.
Okay, thanks. So, who wants to move to command? General Chusseau?
Yeah, of course. Ukrainian shows us that.
And sorry to interrupt. Also, if you want to spend a few words on
I will touch that, by the way, that they are, as I was saying in my presentation, using the perfect balance between big capabilities and innovative capabilities, coming sometimes from the civilian side, coming from the innovative development side, whatever they are coming from. Sometimes you can use some civilian capabilities, sometimes you can't use some civilian capabilities. You have to develop new capabilities. The way they are doing that is a way using risk and mitigation of risks. I mean, they innovate in every kind of area, even on big capabilities. So they take some Western capabilities, they adapt them, and they are very agile and very responsive to the threat because they use everything, whatever it's a big capability or it's something coming from the civilian side, and adapt them to the operational need. So they have this mental ability to do that. It's a really innovation spirit.
Thanks. Okay, we have time for one more comment. You can do both if you do it telegraphically.
Very telegraphically. First of all, I do agree on what we see on the screen in terms of, I think that we should proceed hand in hand. Concerning Ukraine, two elements here very quickly. The first one leads to the correct balance between quality and quantity in the system that we have to develop. It was something addressed this morning, I think is absolutely relevant and important. And the second point is ingenuity driven by operational requirement or by operational needs. I was very much surprised, even in looking in the reports, on how fast and quick they were able to adapt existing instrument and integrate very different technologies to achieve an operational goal. And that's probably something that we should learn or relearn, to be able to sometimes very much adapt very quickly to what are the operational needs in developing situation. That's it.
Thanks.
To just jump in very briefly, I would say the answer to that question depends on how soon you think you might actually have to fight and whether you think you will have a choice. Because if you have to fight soon, you need to buy off the shelf or be a fast follower at best. And if you think you have 10 years, you can go through your own development process with all the benefits that gains you industrially, etc. One thing that struck me from Ukraine is everyone in the West thought Putin wouldn't invade until quite late because it made no sense to do so. The lesson which we all need to remind ourselves on is deterrence happens in the mind of your enemy, not in your own presentations, and it happens on your enemy's timescale, not yours. And so in this case, what I would say is, if you have to fight in 3 to 4 years in a concurrent situation because something goes down in Taiwan or Korea, and the US is there, and then Russia does something in Europe, what are you going to wish you had bought now? I'm not a great orator, and I'm speaking to 1,900 people, so I'll borrow from a great orator. Winston Churchill in 1937, we must act quickly and we must act now to put our defenses in order. If we do not, history might judge us with those terrible, chilling words, too late.
Thanks a lot. Okay, thank you very much for your attention, and please join me in another final round of applause for our panelists. Thank you.